Right. So today we're doing a deep dive into how software actually gets made.
Yeah, yeah, yeah.
And specifically, we're going to be looking at something called white box testing, which
Mm,
you flagged.
right.
And I think our goal here is just to help everyone listening understand what this is, why it's so vital, and the key techniques involved.
Yeah.
And I think for people listening, this is like your insider's look at how developers actually make sure the software you use works. So
Yeah, yeah, yeah.
let's dive in.
So think of it like this. You're looking at a building
Okay.
and it's got glass walls.
Hmm.
You can see all the internal structures, the pipes, the wiring, everything that's making it tick.
I see.
And that's the essence of white box testing. We're getting a transparent view inside, like into the software's inner workings.
Got it. So it's like an X-ray view, basically, into the code, right?
Precisely.
And this isn't just for, tech experts. I feel like even if you're, not a software developer,
Sure.
understanding this stuff gives you a real appreciation for like the care that goes into making the tech we use every day.
Right.
It really highlights how rigorous they are
Yeah.
in making sure software is dependable.
Mm.
So yeah, let's jump in. So what exactly is white box testing?
So in the simplest terms, white box testing is it's a way of testing software by looking at its internal structure. So it's design, how it's actually coded.
Mm.
You might hear it called other things, clear box testing, glass box testing,
Right.
structural testing. It's all the same thing.
Okay.
The key is we're looking inside, we're looking at the code itself.
Okay. So it's like different from just, using an app,
Absolutely.
clicking buttons,
Yeah.
Yeah.
That would be black box testing.
Right.
So black box testing is where you're just concerned with inputs and outputs, the external behavior. White box testing goes deeper. It's scrutinizing the lines of code. It's looking at the logic, the paths the program takes.
So it's about the journey, not just the destination.
Exactly. We're looking at how it gets there.
Got it.
The aim is to make sure, that everything functions correctly at a fundamental level.
Yeah.
So we're trying to verify the code itself and how it's actually executed.
Okay. So we've established we're getting this X-ray vision into the code.
Yeah.
So the material mentions some specific techniques used in white box testing.
Right.
Can you walk us through the main ones?
Yeah, absolutely. There are several techniques, but we're going to focus on two today.
Okay.
Statement coverage and branch coverage.
Okay.
And each of these targets different aspects of how the software code is executed.
Oh, yeah.
And, just to be aware, there are things like path coverage, which is even, deeper testing of all possible execution flows.
Okay.
But we're not going to get into that today.
Got it. So let's start with statement coverage. What's the core idea?
So statement coverage, it's based on a very straightforward principle. It aims to make sure that every single statement, every line of code is actually executed during testing.
Okay.
So remember that glass building we were talking about?
Yeah.
Statement coverage is like going in and making sure we turn on every single light switch.
Got it.
See if the bulb works.
So it's just like if you have a piece of code that, it does a couple things.
Mm-hmm.
It sets up some initial values, does a calculation, gives you a result.
Right.
Statement coverage wants to make sure each of those like individual, actions
Yeah.
actually is run.
Exactly.
Yeah.
Doesn't matter, if it's a simple instruction, if it's part of a loop that repeats, if it's in a conditional statement that might not even execute. Statement coverage wants to touch each one at least once.
Okay.
Right? And the more of these we execute, the more confidence we have that, specific parts are functioning. But it's important to remember that statement coverage, even if we have 100% statement coverage,
Right.
doesn't guarantee that the code works correctly.
Right. So it's just like a baseline.
Exactly.
Yeah.
It's a good starting point.
Yeah.
But it's not the end-all, be-all.
Got it. So how do developers actually measure how much code they've tested using statement coverage?
So there's a simple calculation. We take the number of statements that are executed by our tests.
Okay.
We divide that by the total number of statements in the code,
Okay.
and we multiply by 100 to get a percentage.
Okay.
So let's say you have 100 lines of code. Your tests run 75 of those lines.
Okay.
You have 75% statement coverage.
Got it.
And for you listening, this isn't just a number.
Right.
This is a measure of how thoroughly the software you rely on, the foundational building blocks of it,
Right.
have been put through their paces.
Okay. That makes sense.
Yeah.
So the next technique you mentioned, branch coverage. It sounds like it's building on this idea of statement coverage,
It does. It does.
but taking it further. Yeah.
So while statement coverage, we said is focusing on each line, branch coverage looks at the decision points.
Okay.
So the places where the program's flow can actually diverge.
Okay, so these are like, if this, then that.
Exactly, or a
I
loop
see.
that could repeat or stop, or
Yeah.
Yeah.
So these are typically found, in if-else statements,
Okay.
various types of loops, got,
Right.
the for loop, while loop, things like that.
Yeah.
Or any other control flow structure that has, multiple potential outcomes,
Okay.
based on whether something is true or false.
Got it.
And what branch coverage aims to do is make sure that we test every single possible outcome of each decision point.
Okay.
So we want to make sure we've explored the yes and the no,
Right. The true and the false.
the true and the false,
Yeah.
of every decision the code can make. So it's like going back to the building.
Yeah.
If statement coverage is about, flipping all the light switches,
Yeah.
branch coverage is like also making sure we flipped them on and off.
Exactly.
You're
We're seeing what happens in both states.
Yeah.
So, the if-else statement you had in your material,
Okay.
I think it's a good example.
Yeah.
It said, if by 10,
Okay.
if by 10,
Yeah.
print greater than
Print less than or equal to 10. So for branch coverage, it's not enough to just have a test where, let's say, x is 15,
Right.
right?
Yeah.
And that would execute the greater than 10.
Yeah.
We also need a test where x is, let's say, 5.
Right. So it hits the other.
Hits the other side.
Yeah.
And, both of those pathways, both of those branches need to be exercised for full coverage.
Okay. So we're making sure we test both sides of every
Decision
Yeah.
point, yeah.
Okay. That makes sense. So just like with statement coverage, there's a way to measure
There is, yeah.
how thoroughly we've tested those decision points.
And, while we don't have the specifics in our material, understanding that there's a metric for this really reinforces the rigor, I think, of white box testing.
Okay, that makes sense. So we've talked about, making sure every line runs. We've
Yeah.
talked about making sure every decision point is tested.
Right.
What are your key takeaways, from understanding all this?
So I think the main takeaway is that white box testing with techniques like, statement coverage, branch coverage, it provides this really detailed, granular view of how the software behaves internally.
Okay.
Right. And that allows developers to uncover potential problems at the code level.
Got it.
So things like logical errors, or incorrect assumptions in the code, or even pathways that might not be executed under typical usage.
Right.
So by systematically ensuring this coverage, of statements and branches,
Yeah.
we increase the likelihood of catching these subtle but, potentially critical bugs
Yeah.
early on in development.
Right.
And that leads to more robust, more reliable software for everyone.
It really emphasizes, it's not just about, creating a slick UI or
Yeah.
whatever. There's a whole, internal world of checks and balances happening behind the scenes.
Absolutely.
Yeah.
And I think it highlights that, software quality isn't just about the absence of errors
Yeah.
that a user might see.
Mm-hmm.
It's about meticulously examining, the underlying code, the logic, to make sure everything operates as intended.
Yeah.
Even in like less common scenarios, like you
No.
said, edge cases, things like that.
Right. So, given these, techniques that we've talked about, looking at the code directly, testing the paths, what kind of hidden issues do you think are these best at finding?
Yeah.
And what kind of things, might still slip through?
That's a great question.
It makes you think about like how complex software really is.
Yeah. And, I think white box testing, and especially techniques like branch coverage, they're really good at uncovering those logical errors within specific sections of code.
Okay.
Right. Problems with the flow of execution, making sure that, all those paths are functional within, a function or a module. But it might not be so good at, identifying those broader system level issues,
Okay.
where different parts of the software interact, unexpectedly.
Right. So it's very granular.
It is.
It's not about the big picture necessarily.
And it's not going to be good at catching those usability problems
Right.
that a user might experience.
Yeah.
Right. And those often require different testing strategies that focus on that overall system behavior,
Yeah.
and user interaction.
Yeah. It's a good reminder that you need a bunch of different methods to really feel confident, I guess.
Comprehensive approach is always best.
Yeah.
And it leaves you wondering, even with all these internal checks,
Right.
what unforeseen interactions or environmental factors
Yeah.
might still cause unexpected software behavior in the real world.
Yeah. There's always that unknown, right?
Always, always.
Yeah.
All right. Well, this was a fascinating look, I think, at white box testing. I really appreciate you walking us through all this.
My pleasure.
And yeah, I think we've given everyone listening a really good sense of how important this is
Yeah.
and how it helps make software more reliable.
Absolutely.
So thanks again.
Thanks for having me.